that we just went through, you saw data moving back and forth between, say, integers and doubles, doubles and integers, integers and booleans, characters back and forth around from type to type. Yes, we wrapped up with an overflow, but not all type conversions involve overflows or loss of data or are somehow bad. In fact, taking data in a variable of one type and putting it in another type is a very common thing to do in C++. And the compiler will take care of the conversion if the types are compatible. Sometimes it will just have nothing to say about the whole process. You have an integer, you want to put in a double, no big deal. It will promote the integer value to a double value and put that new promoted double value into your variable. If what you're doing could cause a loss of data, the compiler will give you a warning. If the types are completely incompatible, like a double quoted string trying to be put into a character, then the compiler will give you an error and the application won't run. Once you have it compiled and all you have is warnings, you're not going to get runtime errors as you move things around from one type to another. That stuff is taken care of at compile time, and there are not checks at runtime. That's a performance feature. Now, this means that you mustn't ignore compiler warnings. Some compiler warnings are telling you about serious possible bugs, like throwing away all of the decimal places in your floating point number when you put it into an integer. The problem is if you have a large project, you have normally 307 warnings. You might not notice that this morning you have 308 warnings, and you really need to go and look at the new one because it's a bug waiting to happen. The solution to this, of course, is don't have 307 warnings. There's a mechanism called casting that lets you tell the compiler, I know what I'm doing here. This is my choice. I know I don't have an integer, but I want you to turn it into an integer and then put that newly made integer into my variable. Then there will be no more warning, and it's clear to anyone who's reading your code what it is you're trying to do. Now, can this be dangerous? Of course it can. If that's a double with points of information in it that you needed to keep and you cast it to an integer and throw them away, nobody's going to stop you. C++, the saying goes, makes it easy to shoot your foot off. And the compiler, when you cast, basically says, well, okay, it's your foot. You know, you're asserting that you know what you're doing. I'm going to believe that you know what you're doing. These traditional casts, which are sometimes called C-style casts, are not the absolute best practice. After we've gone through templates in this material, I can show you some safer and better casts. But for now, I'm going to go through traditional C-style casts, which basically tell the compiler, back off, I know what I'm doing. And while we're talking about converting types back and forth, I also want to show you the suffixes that you'll occasionally see on numbers, and they're only allowed on numbers, to indicate the type of a literal. So a literal is a number like 0 or 1 or 2.2, and these suffixes can say, I'm telling you that this is a long, or I'm telling you that this is a float. And that's done as a form of casting to say, I would like to take a long 0 and put it in here, as opposed to a default integer 0. There's not a lot of compelling reasons why someone getting started in C++ would care what size of 0 they put into a number. But when you read it in someone else's code, it can just kind of stop you in your tracks and you say, what the heck is 0L? So I want you to see it so that you recognize it when you bump into it. Let's add some casts to the demo to make the warnings go away. I'll just rebuild the solution so that you can see the warnings. Now I've commented out all of the character code again. So these warnings are putting that double 2.2 into I4, forcing our Boolean to take an integer, and forcing our Boolean to take a double. If I go to each of these in turn and cast, here's how it's done. Say round bracket, the type you would like to turn it to, close round bracket. This says take D1 convert it to an integer, and I asked for it, so please don't warn me about what the consequences might be. And now that that's an integer, go ahead and stick that into I4, which of course will trigger no warning because sticking an integer into an integer is fine. Let's try doing the same thing here with our flag. Take I1 and cast it to a bool. And we'll take D1 and we'll cast it to a bool also. And I'll build the project again. Now, interestingly, the casts don't really make the bool any happier because you're still taking the number and converting it to a bool, and there's still a possible performance warning associated with it. But you notice that the other warning has gone away. There's a better way to solve this problem when we get into flow of control and ifs and so on. You'll see how to do that. Here, we have at least gotten rid of the warning that came from this possible loss of data. And so you can see that putting casts in takes some of your compiler error messages away. Now, if I run the application using Control F5, the output is exactly the same as on all of the other runs. You still have the truncated value 2 put into I4. Nothing in casting suddenly enables us to stick doubles into integers and have them stick around as doubles. They get truncated into integers. We've only made the compiler behavior change. We haven't made any of the runtime behavior change at all. So casts are really just a way of telling the compiler, I know what I'm doing, please don't bother me about it anymore. Now I said I'd show you the L suffix. Let's just go, say, here and stick an L on that. So now I'm going to initialize our integer I1 to a long 1. Now normally longs don't fit in integers, but because 1 is small, the compiler actually isn't going to have an opinion about this. So I'll just compile with the keystroke. And you see I just get the same 2 warnings about the bool as before. So it's perfectly happy to put 1 into our integer. And 1L is a number, despite the fact that it doesn't really look like 1, and it wouldn't be 1 if you wrote it on a piece of paper. Introduced you to the idea of types, that variables have a specific type like integer or bool, and that you have to declare a variable before you use it. You can declare and use it all in one, or you can declare it and then give it a value however many lines later you want. And obviously, once it's got a value, you can use it in other calculations. You saw as simply assigning the value of, say, I1 into that double. Different types for different kinds of data. They have different lengths. They have different maximum values in the case of numbers that they can hold. The compiler knows all this and will help you as much as it can. There is also documentation on MSDN if you really start to get worked up about whether or not you can hold 2 billion in your integer or what have you. You should at least have a faint inkling in the back of your mind that overflow can happen, that you don't get error messages at runtime when overflow does happen. The best way to avoid this is don't put numbers into the car type. Put numbers into something like int, and then you're almost certainly not going to have a problem with overflow. Occasionally I'll see people who have database keys or other really, really big numbers, and they're putting them into, say, a short, something that can hold 32,767, and when they crank over to 32,768, 970, they run into an overflow and are really confused and don't know what's happened. If you remember that overflow exists, you'll recognize this problem when you come across it. Just using ints most of the time, unless you happen to be in an environment where every single byte counts, is the simplest way to prevent overflow from being a problem for you. When you want to convert between 2 types and you're getting a compiler warning about it, stop, because remember the compiler is your friend, and think about whether you actually want to throw away data, truncate a value, whatever it's warning you you're going to do. And if you do, then say so by casting. For now, with the round brackets as we showed in the demo. Later, after we've covered templates, I'll show you a better and safer way to cast. For now, casting tells the compiler, don't warn me about that, and that ensures that you'll continue to see warnings that you need to see from situations that you haven't thought through and weren't doing on purpose, and that's when the compiler will help you out.